recording to be in progress. Okay, so this week, last week that I should actually record on this chapter 2 Fourier series part 2. Then I decided that actually this chapter need to be discussed in class. Okay, chapter 2 Fourier series part 2. If normally our class will be 2 hours synchronous lecture, 1 hour tutorial synchronous, and 1 hour lecture asynchronous. Okay, so this one should be on the recorded last time, only recorded. Okay, but I decided not to record it, actually to discuss in class, because it's a bit challenging, this one. Okay, so we have touched on the previous week about the sinusoidal signal. Okay, you getting to know about Fourier series. Okay, Fourier series is actually we try to visualize the time domain signal, periodic time domain signal, time domain signal from the frequency view. Okay, and effect of Fourier series characteristics. So this 1, 2, 3 have been touched on the last week. Okay, on last week. So now we will go to this Parseval relation and applications of Fourier series in the circuits. Okay. Okay, so let's recall our complex Fourier series. So when the word is complex, mean it is involved the use of exponents. Okay, and when that we refer to complex, mean it is a double-sided. So always remember, okay, when we recall about complex, it is exponent. When it is exponent, it is double-sided. Means we have the positive portions of the graph and we have the negative portion of the graph. Okay, the signal comprised of the positive and negative parts. Okay, when we touch about the complex Fourier series. So as we see here, Vt equals to C naught plus this sigma. Okay, so this one is your DC. Okay, DC value. It is not. It is independent of phase. Okay, DC, right? Independent of phase means not dependent on phase. Then you have the positive and negative portions of the graph. Okay, so please focus. Sometimes I will pick up names to ensure the student actually listening. Okay. So you can see here, this is n from 1 until infinity. Okay, you must see that this one is actually very important. Now you see that this is n from 1 until infinity, and we will have Cn, E, J, N, omega. So we have positive part and we have negative part. If we have negative infinity here, what will it be look like here? Okay, this is question for you. Okay, try to think. If it's negative infinity here, what it will be look like here? Okay, so you see this is the graph. Okay, this is the triangular signal. Okay, triangular signals. So you can see that 0 until 20. Okay, this is a complete period, which is 20 milliseconds, and this is your amplitude. Okay, so this is the two, but it's begin at 0. And if you see from this graph, is it an even or odd signal? Is this even or odd signal? Google check. Is this even or odd signal?
It's even.
Yeah, it's even. It's even because if you put a mirror here, it is symmetrical. Okay, one of the example that it is odd signal is that sine signal, because sine signal is we have positive here, but the counterpart will be negative. Okay, so yes, it is even signal. So so this is the step for us to solve for complex Fourier series. First is that we refer to Fourier coefficient table for the coefficient C0 and Cn. Okay, in the exam or in this new syllabus, you guys actually just to use the table and to solve for the Fourier series or whatsoever. Okay, it's given table. So last time I told you guys, right, in my times, actually we integrate this. So the syllabus actually made easier. Okay, the syllabus actually made easier. So hopefully you will score as well. Okay, because it's made easier. Last time we have to integrate. It's even more difficult last time. Okay, more challenges and more challenging. Okay, So refer to Fourier coefficient table, C0 on Cn. Okay, you'll be given some table later on, we will see. Okay, I'm not sure if the table here. Okay, the table. Okay, you are given table. You can see the characteristic of the table. Okay, first is a name. Okay, the type of the wave. Okay, you can have square wave, sawtooth, triangular, and others. Okay, if they, I think this table is not full. Okay, you will see later on. Okay, waveform. This is the waveform. You can see this is the amplitude. Okay, all of these have meaning. Okay, it's significant. So please read carefully when you see the table. And this T naught is the complete cycle. This is sawtooth. Okay, sawtooth. Complete period is from this 0 until T naught. Okay, and then you can see this is the DC value. Okay, x naught over 2. You can see here x naught. X naught means it is amplitude. If this is 2, means 2 divided by 2 is 1. Means C naught is equals to 1. And then you have Cn, J, x naught 2 pi n. Okay, this is J. Okay, and so on. Okay, and then the comments. Okay, there is comment here. If Cn is equals to 0, if n is even. Okay, so this one is obviously is not even. Okay, it is odd signal, but Cn is equal to 0 if Cn is equal to 0 for n is even. Let's say 2, 4, and so on. Okay, 2, 4, 6, 8. Cn is equal to 0. So for this, maybe you only solve maybe for C1, C3, C5, something like that. But again, depends on the question. Okay, the same goes for here. Okay. Okay, so if you see this graph, okay, later on Fourier series on the amplitude spectrum and phase spectrum, I will explain. Okay. Eh? Eh? Why I cannot? Why is it like this? Anyone can tell me? Oh my god, this is new window. I want to search for pen. Okay, pen. Okay. So when we have amplitude spectrum, okay, your amplitude should be always positive. Okay, for the complex exponential. Okay, it should be always positive. Means it's always on the positive side of the graph. Okay. However, if for the phase, it can be like this. Okay. Usually, for example, usually it's like this. Usually it's like this because later on, you know, we have E negative J, something like that. Okay. And blah, blah, blah. So this one is usually negative. This one is usually positive. And this one is usually always positive. Always positive. So if you guys later when you solve the equation, okay, that you get this magnitude negative, you have to make it positive. Okay, you have to make it positive for using some using equation. For example, E j theta equals to cos theta plus j sine theta. Okay, j sine theta. So you will learn, you will need to familiarize yourself with pi over 2. Okay, will result in what? Okay, you fill in pi over 2 and it will result in what? Because later on, for example, if this is negative 1 and this is ex, ejx, all negative 1 here can be replaced with jx here, for example. Okay. So from the table, okay, you compare directly the given graph with the one in the table. Okay, if you are given the graph, and you will determine the x naught and t naught. Okay, t naught is actually the complete cycle, and then you will calculate the Cn values up to the required number of harmonics, and write the complex Fourier series for the whole signal up to the required number of harmonics. If the question asks you to do up to 5 harmonics, then n equals to 5. Okay, something like this. So this is this table. So you have more table. Okay, this one is full wave rectified. I think you learn in your electronics. Okay, you know how we actually obtain this rectifier. Rectified. Okay, I think you guys can go through your previous electronic devices, if I'm not mistaken. Okay, so you have full wave rectified. So you can see it's 2x naught over pi. So it's always different. So you need to see which kind of graph they are given, and you try to derive the Fourier series equation. Okay, square wave, impulse, train. Okay. Okay. So this is the given graph just now. Okay, ST, V, volt, and 0 until 20. So this is the general equation. Okay, the general equation for the Fourier series. If you can see, okay, my question earlier just now, okay, my earlier question just now, like this, okay, what if we have this as in negative infinity? Okay, so I'm asking, then I answer myself. Oh my, okay. So hopefully your mind still, try to think. Okay, so this one is negative. If negative infinity, what will happen? If negative infinity is simple, it's actually just we consider both positive and negative sides. So this one made you will simplify it to be like this. Okay, and n is not equals to 0. Why n is not equal to 0 here? Where we have the n? Where is n equals to 0? Anyone can answer before I pick your name? Why here is n not equal to 0? Where is n equals to 0 then? Anyone care to answer before I pick up your names? I have names here. Nusha Mimi. Why n is not equals to 0 here? Then where is n? Then where is n equals to 0? Nusha Mimi.
I don't know.
Don't know, huh? Okay. It's really, it's red alert for those that didn't know, because this one is, test one cover all of this, okay? All of this chapter 1, chapter 2. Nurul, let me see, Raihana Kamaruddin, why we have n equals to 0? Why we don't have n not equal to 0 here? Then where is n equals to 0? Raihana?
I think 2, doctor. When it's 2.
It's 2? Okay. Okay, correct, Raihana, correct, okay. So here, n equals to 0 here. Okay, n is equals to 0. We don't have n equals to 0 here because n equals to 0 is here. Okay, and it is actually here. Okay, it is not 2, but it's actually at this position. Okay, so this is n equals to 0. That's why here only touch from other than 0. This is n0. Okay, so correct. And then here is the now we know that this is triangular wave. Okay, so we get this triangular wave graph. Okay, here is your C naught. Okay, C naught x naught over 2. Okay, x naught over 2. Say then you refer to the graph. Your C naught is actually what? Your C naught is actually the amplitude is 2. Okay. Macam kejap sorry, macam okay, it's not maximized. Okay, now it's okay. Okay, so from the graph, your amplitude is 2 and your T naught is 20 millisecond. Okay, you know that actually omega is equals to 2 pi f and f is equal to 1 over t. So that's why you have 1 over 20 milliseconds. So you will have 100 pi. Okay, 100 pi. So this is from the graph, and this is the complex Fourier series that you try to relate. Okay, so you have this, your C naught is actually x0 over 2. Okay, this is given by the table for the equation of triangular wave. Then you modify your Cn. Your Cn is actually this one, negative 2x0 over pi n square. Ej n pi omega t. Okay, so you will have this Cn and this C0. Okay. Okay. Maybe I should try to change screen. So please refer to your slide. Every one of you should have your slide. Okay. Please refer to your slide. On the page of one, on the page of 7. Okay, because I won't writing the question. Because it will take some time if I write the question again. It will delay all the will delay our class. Okay. Okay. Let me see. Okay. So this is the pen. Okay, where's my pencil? Okay. So you can see from the 6, you can see from 6, and now we try to discuss on the number 7. Okay. So because the triangular wave you already obtained xt equals to c naught plus this one, okay, and not equals to 0 and so on. Okay, I think you guys can it's a bit difficult to write on the screen, but I try. Okay, Cn E Jn omega not t. Okay, so you know that omega is actually 2 pi f. Okay, and f is equals to 1 over t naught. Okay, so this one, that's why when you have this one, you can solve for your omega. So, and this is triangular wave, so it is given that the triangular wave is actually like this. Okay, based on the table. So 2 over 2, this is actually your x naught. Okay, your amplitude. Okay, the max. Okay, amplitude, and then you have plus here. Okay, then you have the sigma here. Okay, so the question is asking up to, if I know, third harmonics. So if it's third harmonics, mean n equals to 3. Okay, so you will need to settle until n equals to 3. So, but this is the general equation first for for triangular. You need to write all of this. If in the exam that you didn't write, I will cut some marks. Okay. And then we have here 2. This one is actually x naught. Okay, if you refer to the table, this one is x naught. And then you have pi. Then you have your n. And you have your square here. Okay. Then you have E, J, N 100. Okay, how you get this 100? Anyone can tell me? How you can get this 100 pi t? How you get this 100 pi t? Anyone? It's better to participate in the class and make some guessing. Better than you when in the test come, then you didn't know actually what you didn't know. Okay. So this is your omega. Okay. Yes, calculate the frequency. Yes. 2 pi f. Thank you. Who is this just now? Thank you, Siti Khadijah. Okay, this is 2 pi f. Okay. So, and then you know, and then it's given that, so here you can know your C naught. Okay, you can know your C naught, which is 1. Okay, and then you because it mentioned third harmonics, mean n until 1, 2, and 3, until the third harmonics. Okay, so if the question asks you about 5 harmonics, until 5 harmonics, then you need to settle until n equals to 5. Then based on the PowerPoint there, you can see it is C1 equals to C2 equals to something. Okay, this one is actually you just follow the table. Okay, so let me see from the first table is actually Okay, so from the triangular wave, okay, it given to us that actually the Cn, okay, from the triangular wave table in 4 pages, it mentioned that Cn is actually like this, right? This is the table, okay. For triangular wave, it is Cn is actually negative 2 x naught over pi n square, okay. So like this. So for n1 here, for n1 means that you just need to settle accordingly. 2, okay. You need to practice because you can get more all sort of graph, okay. You can get any of the graph there, okay. So of course the question here is about triangular, but this will not be asked on triangular only, okay. I mean test 1 can ask on anything on chapter 1 and chapter 2, okay. So then what else? Pi. Then this one is n1. So that's why you have 1 here. And you have your square. Then you will have negative 4 pi square. Okay. So and so on. Okay. And so on. So because I cannot write everything here. Okay, where were we? Okay, now you settle for your CN. Then after that, you obtain ST. Okay, you see the question there, ST equals to 1 plus 4 pi square E negative J 100 pi T, okay, E negative J pi. Okay, this is the from the solution. I highly suggest each and every one of you to try this example. Okay, of course, if you really want to learn, you will try to solve the example. Even you will not try to take as it is, because if you see, then you think like you're reading comics, and if you don't try to solve it, you will see that actually many things that you don't understand. Okay, so example here, of course, is the most is the easier one to help you to understand. So that's why please do at your own leisure time. Okay. This reason why I make it red. Later on, I will ask question to all of you. Okay. So, okay, if you guys see at the slide number 7, if you guys can see your C1 is equals to negative 4 over pi square. And then your C3 is also negative 4 over 9 square. So this one is actually, when you solve this one, 3 to the power of 2, that's why 3 to the power of 2. That's why you have 9 there, okay? So and then you have C negative 1 is actually negative 4 over pi square, and C negative 3 is negative 4 over 9 pi square. So this is at slide number 7. Then you are given this answer. So if you see this question, okay, you don't have any negative, okay? You don't have any negative. It's all positive here. Okay, it's all positive here. Okay, whereas in the earlier parts that you actually obtain C1 equals to negative 4 over pi square. So anyone care to answer how that we lost the negative? I mean, how that we can come up with the equation with all in addition operation. There is no negative. Anyone care to answer? Anyone care to answer? Why previously our C1 here is actually negative 4 over pi square. Our C3 is equals to negative 4, 9 over pi square. Our C3, our C negative 1 is equals to negative 4 over pi square. And our C negative 3 is equals to negative 4 over 9 pi square. But why in the complete equation, the finalized equation, why we didn't have this negative? Anyone can answer? Before I pick up names. Why we no longer have negative in our final equation, but our earlier obtained equation, our C1 until C1, C3, C negative 1, C negative 3, all with negative. Anyone care to answer? Just guess, you know. Be an active participant in the class. Okay. I think it will be interesting later on if I to meet you guys physically. Anyone want to answer? Uhud Samir. Okay, One Nur Yasmin. Maybe because we use amplitude. Okay. One of the reason. Okay, good, Yasmin. But you don't. But it's not still correct. But don't really answer my question. But it's good. We have to make it positive because our amplitude spectrum must always negative. Must always positive. Okay. So in any way, even though we have here the negative part, okay, the equation initially should be negative, right? All of this. But why? But we have to make it positive because our amplitude spectrum, okay, because our amplitude spectrum for the complex exponential should always be positive. So we need to find a way to convert that positive, to convert the negative part, the negative value into positive. So what we do actually to make this question to be all positive? Anyone care to answer? Okay. No, Yasmin, answer why we need to make it positive. Okay, that's good also. But the other thing is how actually we manage to convert the negative part of the equation to be positive. Okay, Adiloma modulus. Okay, modulus is actually when the graph is actually mentioned modulus there is actually it's always positive for all. But how we make it to be positive first? Okay, if modulus mean we need to put modulus here, but we didn't put modulus there. What we do actually to convert the negative part of the equation, negative parts here to be all positive, so that our amplitude spectrum have all positive value. Anyone other answer? But remember, amplitude spectrum, you need to put modulus. Uhud Samir multiply with negative 1. Not necessarily true, means this, if you multiply with negative 1, means the equation here will be negative. Do you understand? So you cannot change here. It still need to be, oh my God. It still need to be ST. Because if you multiply the entire equation with negative 1, then this one will be negative, which is wrong. Okay, it is still ST. It is ST, but we need to do something to convert. Okay. Any other question? Any other? Okay. If I were to wait, maybe end up we don't finish. Okay. So actually, we need to convert. We need to convert all the negative part. Okay. For example, here is negative 4 pi square. Okay. So back to your theorem. Back to your Euler's theorem. Okay. Refer to your Euler's theorem. Go to your previous slide. I don't know which slide. Chapter 1. Chapter what? You have to remember which chapter, okay? Which chapter? Chapter 2 or chapter 1, where we learn about Euler's theorem, okay? I know, but I want to student, but do you know which chapter? So Euler theorem, okay? Let's go to Euler theorem. What do Euler theorem teach us? Okay. Can someone tell me the complete equation? Euler theorem that have like this: cos n plus j sine. Anyone can help me to complete this? It's not amplitude equation, Anis. Now I'm trying to teach how to convert. Okay, refer to the Euler's theorem. Can anyone help me to complete this equation? Euler's theorem. E equals to cos j sin theta. What is this? What is here? Can anyone tell me?
J theta.
You dah tengok graf ke? Sekejap You dah tengok, no tak? Tengok slide sini. Can give me the correct one, I mean the complete one. E equals to cos what? J sin what? From the previous lecture note. Euler's theorem. It's important, you guys, because you need this skill when answer the question.
EJ theta, Doctor.
EJ theta. Lagi?
Cos theta, J sin theta.
Okay. So all of this actually come from this, okay? How actually make it negative? I mean, how to make the negative part to be positive, okay? So first, this is J. This is J. Sorry for the bad handwriting. So this is J. So now you can see, we try to convert the thing, okay, into positive. Okay, we try to make this equation to be positive. That's why we have this friend here that I earlier make as here. Okay, I make in red. You can see here. Okay, you can see here is negative j pi. So it's actually, you try to see. I just reverse engineer, but you guys need to discover yourself. You guys need to discover E j pi, okay, cos pi, okay, cos pi plus j sin pi, okay. So what is cos pi? Equals to what? Anyone? Cos pi is what? Go to calculator. Cos 180 is what? 1, okay. Is it 1?
It's not 1.
-1, Doctor.
-1, okay. This is -1. How about sin theta? J sin theta? Okay, it's 0. So 0. So you can see actually this one is equal to -1. So that's why all the -1 here, which is, earlier this one is -4 over pi, right? So -1, you can replace with this guy, E j pi. I think you guys miss the negative. Siapa tadi yang cakap tadi yang kat saya tu? I think you miss the negative. There is a negative here. Ada negative here. Please check. There is negative here. Can check the equation. Do you have a negative?
There's no negative, Doctor.
Positif saja.
Yes.
Wait, I try to see the answer. Negative j pi, negative j pi, negative j pi, negative j pi, negative 1. Oh, okay. So here, -1. We come back here, -1. Okay. So now -1 will be replaced with here, E j pi. Okay, E j pi. Tak ada space. So your C1, okay, if you have -4 over pi square, okay, it's 4 over pi square, okay. So to have the negative, to get rid of the negative, replace with E J pi, okay, E J pi, and we have then you can plug in here. I'm not sure why this one is the negative J pi. Are you guys giving me the correct formula or what?
Yes, doctor.
Wait, I need to check first. Negative 4 pi square 4 pi negative J pi negative J pi negative J pi negative J pi. Negative 1. E negative J pi. So where is this negative comes from? Negative J pi. Ada typo ke? Kejap Sometimes the slides come with typo. That's why I cannot give the slide earlier. The risk of having the slide earlier in your hand, you have to be alert on any typos or whatsoever. If I give you later, I already amend if there is any typos. So this is the reason, but student request earlier, I give earlier, but you have to be to be alert if there is any typo. Okay. Because it's normal human make mistake but okay, let me see first. Complex negative 2 pi x naught j n omega t. Negative j pi. Four pi 4.9 negative j pi plus okay. Wait for I want to check this first. Wait for but the basic is there. Actually, how later on you might to manipulate this. Okay, maybe you need to use pi over 2. Okay, let's say maybe you need to use pi over 2. If pi over 2, what do you obtain here? Can anyone try to do this before I try to see, check the typos? If this is pi over 2, okay, what we will have here? What we will have here? If this is pi over 2 all inside here, what is the answer?
1, doctor.
1. So if you want to settle for 1, okay, and so you need to use pi over 2, means E J pi over 2, okay, to replace with the 1, okay. Therefore, I want to check. I also don't know if you guys actually telling me the right equation, but actually that is correct. E J pi cos theta J. That is correct. I don't know why there is negative J pi here. Where do you guys see the Euler theorem? At which slide? Chapter 1 part 2 or what? Chapter 1 which part?
Chapter 2 part 1, doctor.
Chapter 2 part 1 Chapter 2 part 1. Chapter 2 part 1. Okay, sekejap saya nak tengok. I need to see the slide also. Maybe the slide itself have typo. This slide, chapter 2 part 1. Sekejap
Slide 11.
Slide 11 Negative J theta cos theta J sin theta. Betul ni equation ni. Okay, the equation is correct. The equation is correct. The one that in chapter 1 part 2 chapter 2 part 1 page 11 is correct. No, nothing wrong there. Okay, I'm not sure why there is some wrong with here. Chapter 2 part 2. Okay.
Doctor, may I interrupt?
Boleh
Um,
interrupt.
I think if you use radian in calculator, we will get cos pi equal to -1. But if we didn't use radian, we will get 0.999. So I think we have to use radian in calculator.
Yes,
So
yes,
we'll get
pakai radian.
-1.
Yes, you need to use radian. You guys don't use radian? You need to use
We do,
radian.
we do.
You put the mod radian. Okay, you need to solve using radian. Cos pi -1 and then sin pi 0. Okay, so negative cos pi -1 cos pi over 2. Wait for one. I don't know why is it negative there. 0. Okay, so it is cos pi. So this equation is this is correct, but I don't know why there is a negative here. Maybe I will check. But basically the way to solve is like this. You will replace anything. You replace anything. I mean, you replace with some method to actually ensure that your amplitude spectrum always positive. Okay, to ensure that your amplitude spectrum always positive. Okay. Ini kejap ini tak puas hati segeram saya nak check je kenapa dia negatif. Saya ada salah kira ke? Saya ada salah
Betul.
Yes.
Kalau tengok kat saya search Google je lah. Kalau dia pakai negatif J theta tu kan, dia punya equation sama dengan cos theta minus J sin theta. Kalau guna negatif J theta tu lah.
Mana kalau guna E negatif J theta ni?
Dia jadi cos theta minus J sin theta.
Oh, this one is actually E kalau sini negatif cos sini negatif. Actually Euler's theorem. Thank you, siapa cakap tu tadi?
Intan.
Okay. Thank you, Intan. Actually when we go to Euler's theorem, space saya ni pula tak cukup untuk tunjuk semua. When we go to Euler's theorem, we have the cos formula. We have cos. Okay, we have cos formula equals to what? Okay. And then we have sine formula equals to 1. Okay. Sine formula, if I'm not mistaken, below you have 2j. Okay. This one we have 2. Okay. You guys need to refer to your previous chapter. So this one, and then you have exponent part here. Exponent part here. E minus E something. Okay. J pi and J pi. Okay. So this one rearrange can then obtain what Intan said just now. Okay. Then obtain what Intan said just now. So J, to bring it up, to bring the J up, it need to be, you need to put the negative on the here. Okay, to bring the J up, it will be negative on the top. Okay. Never mind, I will check this later on. Why we have negative J pi. But basically the way to solve is like that. Okay, but I put this first. I will check later on. Otherwise we will waste the time. Okay. Okay, I put into the slide. Okay. Taken that if that is correct, okay, if that answer is correct just now, okay. So then the next step you need to do is actually to sketch your amplitude. Okay. So make sure you label that properly. Sometimes here can be frequency, sometimes can be omega. Okay. So in this case is omega. Okay. So this one is amplitude. So amplitude. C. Follow the slide. C. Cn. Okay. And because it is always positive, you need to accompany with modulus. Okay. Just to show that it is always positive. Okay. So that your label should also should also be meaningful. So this one should be Cn modulus, not only Cn. Okay. Then after that, you need to put the plotting. So first is 1. Okay, you have 1 here. N0 is 1. So for example, 1. And then later on, you have 100 pi t. So this will be 100 pi. 100 pi. Okay. And then second, you have what? 300 pi. Okay. So the negative part is negative 100 pi. Then you have negative 300 pi. Okay. Then you need to plot the amplitude. So this is 1. Okay. Pendek pula here. Okay. 1. Then the next is 4 pi over 4 over pi square berapa? 4 over pi square berapa? The amplitude. Berapa 4 over pi square ni? Oh, 0.4. Okay, 0.4. So it's a bit shorter. Okay, 4 over pi square. And then the second one is at 4 over 9 square berapa? 4 over 9 square pula. So 4 over 9 pi square berapa? What 4 equal divided by 9 pi square? So it is 0.04, much more smaller. Okay, so even more smaller here, 4 over 9 pi square. So because this is modulus and we try to make it always positive, so you can see that it's actually like this. Okay, just like double-sided. Okay, so actually the difference between the double-sided, okay, the double-sided, this is exponential, and later on if you want to compare with combined, if you want to say to compare with combined trigo, combined trigo is actually you only have cos. Remember, you may have the complete trigonometry Fourier series is actually C0 plus sigma cos plus sine, right? But when you plotting, you need to plot the combined trigo, mean only have cos. Okay, this one is single-sided. But if it's request for you to plot double-sided, it need to be if it's a request for you to plot single-sided, it need to be in combined trigonometry Fourier series that only have cos. Mean you need to convert the initial equation that consists of cos and sine into cos. Okay, you can know, right, by inputting what maybe pi over 2 or whatsoever, in order to convert this sine to have the cos part as well. Then combined trigo, you will have totally in cos. Okay, totally in cos because you're going to plot a single-sided. Okay, so the single-sided combined trigo. Okay, so maybe you have here something like this, and this is actually usually is double than this, means it much bigger. Okay, then when we want to do double-sided, or question asks us to do double-sided, means it asks us to do complex exponential. Complex exponential means you have the exponential inside the question, which results into double-sided graph like this. Okay, double-sided graph, and then you will notice usually this one is double this magnitude. Okay, double than this magnitude. Okay, then this is your amplitude spectrum. Then later on, to be complete, if you don't answer with this phase spectrum, is not complete. The next is actually to have this phase spectrum. Okay, so taken that the E negative J pi correct, if it's correct, okay, then it is, you need to you will plot like this, 100 pi, you still have 100 pi, then you have 300 pi. Then you can see that actually we have all the phase is actually negative J pi. Okay, this one that I think I will check later on. Okay, okay, so all of it is in the negative parts. Okay, negative part. Okay, maybe the equation is answer is correct, but maybe we miscalculate somewhere. Okay, I think it's normal because it's live, so maybe some miscalculation there. Okay, so taken that if this is correct, then this is your phase. Okay, this is your phase, negative j pi. So you can see negative j pi. So imaginary in your y-axis. Okay, you can see that this is pi. Okay, the magnitude is pi. Okay, only then you consider your solving the question is complete. Okay, so sometimes okay, maybe this one no need to be snapshot. Okay, no need. Okay, and you need to be careful. Sometimes the question maybe we ask okay, this one you guys can try at home. If the question give you complex exponential, now the question want you to convert it. Okay, the question can give you double spectrum like this. Okay, I mean double-sided spectrum like this, which is complex exponential. Then it will request you to change, to double-sided. So how will you do it? So the question can be from double-sided to single-sided, or from single-sided to double-sided. So question can ask you many things. Okay, provided that if your foundation is strong, should be no problem, because you will know that actually it will tear down to the basic Euler's theorem, to the graph. Okay, how to convert. Okay, because you can know, right, Euler's theorem is the one that actually changed from cos and sine to exponent, and exponent to cos and sine. So you can try this at home. Maybe your next exercise is actually your exercise, but you don't need to submit, but for you, okay, for you, because before you test the real test one, maybe test one. Okay, please prepare. I worry because I worry in such a way is that because my quiz one only cover a small portion of chapter 1. Okay, it did not cover all. Okay, but at the same time I want to help you guys. So the quiz one is not that comprehensive. Normally, if like last semester, my quiz normally will be like a test format. Okay, those that I taught before, they know about this. My point is that so that this quiz will help you to familiarize with the test first, and second, the quiz will cover all of the chapter. This is my last strategy for previous semester. Okay, but this, but of course, the pro and cons. Pro, I give you quiz one only a small portion of chapter 1. Hopefully that you will score. But if you not score, I think you should be worried, because this quiz doesn't cover the entire chapter 1. Doesn't cover the entire chapter 1. So hopefully you will score, because even if you score quiz 1, it is not covering the whole chapter 1. Test 1 will cover all chapter 1, chapter 2. Okay, so you need to know this. You need to know how to convert from this graph to this graph. Okay. Okay, you can have Euler's theorem, right? Euler's theorem help you to convert, okay, from this graph to this graph. So from double-sided to single-sided, from single-sided to double-sided. Okay, you can try this at home. How? Okay. I put into my slide also. Okay, now we go to slide number 11. Okay, slide number 11. Okay, this is sawtooth. Like you know, apa gaji dalam English? I forget. It look like a saw machine. Okay, saw machine. So you can see it look like a tooth. So the name is tooth. Sawtooth. Okay. So write the complex Fourier series of this YT. Okay, and then sketch a double-sided. Okay, now you can see it mentions sketch a double-sided. So if it's mentioned double-sided, you should already know in your mind it is actually complex exponential. But if the question say sketch a single-sided, then what is it? Mean it is a combined triangle. Combined triangle only consists of cos. You don't have sine inside, because in order to plot single-sided, it need to be in cos form. Okay. Then calculate the average power. Okay, so you can see this is the when you're given the table. Okay, you need to see this negative t naught and everything. Okay, so this is your c naught and this is your cn, and there is no remarks here. Okay, there is no remarks here, so no special condition whether cn will be 0 if it's odd, cn equals to 0 if it's even. No such condition. Okay, so this graph, is it odd or even signal? Anyone care to answer? Is it odd or even signal? This sawtooth.
Even?
Even. Okay. Why is it even?
Symmetrical at y-axis.
Symmetrical at y-axis. Any other else? Any other question then who is this just now? Who is given answer just now? Surya, is it? Who is the one that just now? Sorry, I didn't see the name.
It was me.
Oh,
Obada.
Obada. Okay. Who else? Is it odd or even? Okay. So now this I need to ask you. You need to ask yourself, because this foundation fundamental. Okay, good. Also, this kind of example is given. You see here, what is the part? What actually we learn about even signal? Even signal is that the characteristics are the same, regardless it is on the negative or positive part. So if you have four. Okay, if you have 4 at the positive part, it will be 4 at the negative part. And then that is not the only thing. Even it need to look the same across the vertical axis, as if you have the mirror there. Okay, dapat conteng ni? Oh, tak dapat. Okay, okay, so odd, even is like this. Even is, for example, is is cos graph. For example, here a bit tinggi lah sikit, a bit high. So this is your even. Your odd signal is that if you have positive here, then you will have the negative part here. So can you see now the sawtooth? What is it? You can search Google.
Sawtooth.
Yes. Okay, you can search at YouTube. You know, zaman sekarang, your era, everything you don't need really. Sometimes the literature might not explain well, or you want extra information or something, or maybe you confused. You just type sawtooth even odd, something like that, right? So you can know it's actually whether it is odd or neither signal. Okay. Okay. The sawtooth has no particular symmetry. Okay. So it is neither. Okay. You can see here, right? So you can just actually see the answer. Okay. Sawtooth. Okay. Sawtooth. Sawtooth with function that are neither even or odd. Okay. Okay. Good. This question is good. Okay. And then okay, now it mentioned that anti-third harmonic. Okay. Third harmonic. You can try this at home. You can try this at home. You need to settle anti-terminate means you have C1, C negative 1, C2, C negative 2, C3, C negative 3. Okay, this is the answer. And then you can see when you solve, okay, when you solve, macam mana sekejap. Wait, okay. Okay, so when you solve, when you settle for this Cn, okay, here, okay, then you have J pi, okay, this is your Cn, then you have negative J pi, then you have negative J pi, then you have negative J over pi, okay, and then you can see here, okay, it's a bit small there. You can see also here. And then you can see also here. And then this one, we don't want this one. How we going to get rid of this one? We need to convert. Okay, we need to convert. So it goes back to this equation. Okay, Ej theta equals to cos theta plus J sine theta. Okay, here we want to get rid of negative J, means this one must be negative J. So what do you think the value of theta should be? Anyone? Now you have this previous example from the previous example already, right? Now, can you tell me how actually, what is the value of pi here? What is the value of theta here in order for us to have negative J? Because we want to replace this negative J with something else. What is the value of theta here? Anyone want to answer? Actually, answer already there, but I just want to ask. Anyone? The answer is already there. How actually you obtain negative J here? What is the value of theta? Anyone?
Pi over 2.
Pi over 2.
Pi over 2.
Okay. Let's we try. Cos pi over 2 is what? Cos pi over 2?
0.
0. Sin over 2, sin pi over 2 is what?
1.
Huh?
1.
1 Okay. Is it? Really?
Yes.
Sin. Okay, pi is 1. Okay, negative J. Betul ke ni korang ni? So it should be negative, should be negative pi. Try.
Negative pi.
Sin negative pi over 2. So negative 1, right?
Negative 1.
So masuk what? Okay, it's actually not pi, it's actually pi over 2. Okay, it's good. Actually, I know the answer. The answer is there, but I just want to, you know, to help your mind, to help your brain to think. Okay, because in the exam I won't be there. Okay, so I won't be there providing answer. So this actually what? Actually negative pi over 2. Am I correct? Okay. If negative pi over 2, what is our cos?
0.
0. How about this one? If negative pi over 2 is negative J. Negative J, right?
Yes.
Negative. Okay. Then here, that's why here you need to put negative. Okay. Faham tak? Is it, do you guys understand? That's why you have negative J pi over 2. And that's why you have it here. Now understand? Everyone? Understand? That's why you have this. Okay, faham And then this one you have this. Mana lagi? That's why you have here. Okay? You have this guy also here. I think also. Please check, please check, but because I cannot see the entire. But that's why you have some negative there, okay? Okay? So you need to play around with the equation in order to convert into this. So maybe the previous slide, the previous slide that I think there is error. Maybe there is no error. Maybe just now you guys don't really help me. I mean, maybe it's actually pi over negative. Faham ke? Do you guys understand me? Maybe just now the slide is there is no wrong in the slide because in fact that maybe we should use negative. Okay, cuba balik dengan negative. Someone, the previous graph, the one that you macam problem but look like problem. I mean look like error but actually not error. Okay, because like this in this example, the current one that we're having is actually negative pi over 2, not pi over 2. Okay. This one, mana tadi? This one. Saya cuba jap. Cos negative pi. Negative 1. J sin negative pi. Okay. So it's true. This one is cos. This one is negative pi. Betul lah. Okay. So there is no wrong in the previous example. No wrong. Because here you need to change with negative pi. Macam mana saya nak conteng ni? This one negative pi. Macam mana conteng sini? How can I do this? Okay, but this one is negative. This one negative. Macam mana saya nak tukar ni? Nanti salah je pula. Macam mana nak draw sini? Never mind, I take this one first. Here. This one. Mana pula? Hilang dah dia. Okay, tak apalah. Tapi I think you guys know already. I know you guys know already. Okay. This one is actually EJ yang tadi tu. Okay. It's actually I just put here. I think I just put here. Okay. I just put here. Somewhere. Okay. I try so that you guys, because you already lost the page. Okay. So it's actually I put here, but you guys need to try at home. Please try, please try. So E negative J apa tadi? Pi sini kan? So actually cos negative pi plus J sin negative pi. So this is equivalent to what?
Minus 1.
Minus 1. So it's negative j pi. So nothing wrong with the equation. Okay, please try at home. I hope you guys understand. Okay, so how I'm going to take this. Okay, I take this again and I put back to the slide. Okay. Okay, so finish with that. Next question is about double set. Okay, settle. Now is the next one is actually power average. Okay, power average. This one you guys can go on your own. So you see, this is the resultant. Please try at home. I always ask, please try. After this class, you need to try before the next class. Otherwise, you will be blur and maybe you become more heavier and more heavier. Okay. So you can see this is the amplitude spectrum. Okay, it's always positive. Then you can have the phase spectrum. Phase spectrum normally is something like this. It's like odd. Okay, odd. But regardless, this one is usually is always positive, and this one is usually odd. Usually odd. Okay. Then I don't really care much about this because we already covered twice. But this one, power average. Okay. Then the question asks us about how to do the power average. How to calculate power average. So Vt equals to Vm sine 2 pi f1t. Then you have Vm. Vm is actually the peak, okay, the peak value. And you have this is your average power equation. So Vm square over pi, Vm over square of 2, square root of 2 and squared. Okay, this one is covered in your, what they call it? In your circuit theory. In your circuit theory, okay, you guys should know, okay, how, okay, already covered in circuit theory. You guys already covered. So why, how and why we have square root of 2 here? Okay, the normal equation, the normal, not the average. This one is average equation. The normal equation P equals to V square over R, right? Okay, V square over R. For now, this is because this is a sinusoidal graph, okay, sinusoidal, maybe like this whatsoever. Then we have Vm over square root of 2, okay? But how we actually have this square root of 2? So you guys need to know how we actually obtain that. Okay, ada masa ke saya nak cover ni? Because this one is covered in your circuit theory, it shouldn't be covered by me. Should be covered by circuit theory. But anyone can answer before I explain? Because this is you have learned it before. Why we have square root of 2 here? Anyone? 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 Before I pick up the name, this one you need to know, because question can be many things. This one it should be, I'm not sure, if I'm not mistaken, signal and system, maybe prerequisite, not sure. Maybe prerequisite is circuit theory, I didn't check yet, okay, I forget already. But this is actually, you learn from circuit theory. Okay, you learn from circuit theory how suddenly you have square root of 2 here. Why not just V squared? Why not only V? Why you have square root of 2 here? No one can answer. I think no. Oh, this, okay. So this is actually in signals, okay, maximum is 0 dB. Okay, 0 dB means like the maximum. Then when it goes to 50% of its value, it will be negative 3 dB. Okay, I'm not sure it's already covered in your class or not, but you're supposed to know. And then 0 dB. So then this negative 3 dB is actually the value, the half of its value. So you can search, you can try to calculate log, okay, because this dB is actually log. Log 50%. 50% is actually 0.5. What do you have here? Can anyone tell me? Log 0.5.
Minus 0.3.
Minus 0.3. Okay. Minus 0.3. And this actually formula is not complete. It's actually 10 log. So 10 log 0.3. This is the conversion from linear to linear to dB value, decibel value. So 10 log is actually times 10. So you will have negative 3 dB. Okay. So it is actually, this negative 3 dB is actually the value of the half. Okay. When the signal go from 0 degree until the half of its value, negative 3 dB, for example. Okay, half of its value. Okay. So this is negative 3 dB. And then VRMS, you learn also VRMS. Okay, this is not 3 dB, sorry, it's going to the half of the value. Okay, so you learn about VRMS. What is VRMS? Anyone? VRMS. What is the VRMS? Maybe you can even Google, you know. You don't need for me to spoon feed everything. Because you're going to answer this in exam, you know. VRMS is what? V equals 1. Because this is you learn in circuit theory. Root mean square is what? Anyone? Oh, if I'm were you guys, I would be very worried. Okay, so you can see this is the VRMS. Okay, VRMS is usually 1 over set2 V peak. Okay, 1 over set2 V peak. Okay, so this one is actually what? Okay, this one is actually what? You can see here, VRMS is V peak. Okay, V peak over set2. Okay, set2. So this is what? This is actually what? VRMS what? You think, okay, try to think. I ask question and I hope you guys answer. And actually, I already give the answer there. So this is the power average. Okay. Oh, results. I genuinely worry of your test. Okay. So this is Parseval theorem. Okay, Parseval theorem. Okay. Periodic signal carries a fixed finite average power level power signals. Okay, so this is Parseval theorem. In order for you to state your answer, okay, you state your power average in your using exponential Fourier series. So Parseval theorem states that the average power of the periodic signal must be periodic. Must be periodic signal is the sum of the average power in its harmonic components. Okay, so it's the sum of the average power in its harmonic component. So P average is actually the summation of all this. Okay, the summation of all this. If you can see from this equation, you need to see this equation very carefully. You see one by one. Okay, you can see here. Earlier is an square plus bn square. Okay, you can see it's only take the an and bn. It doesn't take whatever cos whatsoever is there. So and then it is started from 1 until infinity, and it is half value, and it is a half value. Second, c0 plus 2 infinity and 1 cn square. Okay, so now it's using 2 and this one is using half. Okay, and here is mentioned that Parseval theorem stated the average power is the sum of the average power in its harmonic component. So first periodic, second sum of average, third is harmonics. Okay, so brainstorm. Okay, just like what I previously shared whatsoever. How actually this, you see, this is 1 over infinity, this one is 1 infinity, and this is 2, and this is n square, this one n square. But how actually to change this half infinity to from 1 to infinity, that you obtain this? Okay, please see. Okay, because this will help you to understand. It will help you understand, because you will ask why, and then when you ask why, and you try to solve, instead of just just accept what is given. Okay, don't just accept what is given. You need to think why it's like that, Okay, so this is why it's like this. Okay, and then the sum, then the entire, when you want to simplify further, this is actually P average extending from negative infinity until infinity, then square of Cn. Okay, here mentioned that Cn is average power in the n harmonic components. Okay, if it says 9 harmonics, something like that. Okay, so you will sum until 9th harmonic. if say 11 until 11 harmonics. Okay. Okay. So if we refer to the same example 2, complex Fourier series 2, you see that you have 1 over pi. Here, okay, the same graph. You see this is the maximum 3, then you have 3 over pi, then usually is becoming more smaller. Okay. Try to do all the example of this slide. If possible today, so that you will know what you don't understand before the next tutorial and for the next lecture. Okay. Average, P average, okay, C naught square. Okay, this is the formula. Okay, you already know this formula. And then now we try to do the average power. Okay, so C naught square is 3 square. And then the next is we settle until the third harmonics. Until the third harmonics, and we want to use this formula. If we want to use this formula, we don't care about this part anymore. Okay, we don't care. Sorry, we use this formula. Okay, we use this formula because we have the value of n0 here, which is 3. So you see 2. Okay, so you can put here 2, and then from 1 until infinity means 1, 2, 3, and then we don't. And then it is modulus regardless of negative positive, means n1 is and n-1 is covered by this already. And that's why we have 2, okay? That's why we have 2, because this one multiply already, okay? 3 over pi square, okay? 3 over pi, and then we square it, okay? 1 over pi, and we square it. And then you have this, and then you have your average power, okay? If you can see this, you have 2, and then this is start from 1, not start from negative. And this you have infinity, okay? Why we put 2? Because it's already covered the negative, and this one is covered negative, and because why? This one is already modulus, okay? Means we covered both positive and negative, but we need to have 2 there, okay? This one, Fourier series application in circuits. Wait, because this one is another. We will not be able to cover this in the. Okay, let me check first. Wait for one. Let me check. Okay, let me check the past examinations. Okay. Actually, if I'm not mistaken, we are not to share the final examination to students. If I'm not mistaken, you can ask your seniors if for the pass. It means we cannot give the complete set, if I'm not mistaken. Okay. Last semester I give the complete set, but it's actually it's not allowed to give the complete set, if I'm not mistaken. Okay. Wait for a while. I want to find the final exam set so that we can see what is actually the complete formula to be asking in the question. I mean complete table. You can see I will share to you guys later on the complete table. When I'm trying to download. 30 seconds. Okay, you can see a lot of why I'm asking you guys why we have this, why we have that, and so please this lecture will be recorded, so you can watch and while you browsing my slide. Okay, so everything that I say, please try at home. Why like this, why like that? Maybe important, not important for maybe not for now, but maybe for your final, because some is a very important skill, okay, important skill. Maybe will be used in later chapter or in your final, okay? Anyway, convolution will not be asked in exam, just like you guys in final exam. Not in quiz also will not be asked. In test also no will ask. It will be we given as group assignment. I will give maybe inshallah. I will give to this week if possible. Inshallah, if I have finalized the equation. I mean finalize what I want to ask, and you will put in the group. Okay, I will try to maximize the group number so that you can have more manpower, and maybe group of 6. Okay, group of 6, because now is your is 34 plus 1, 35 divided by 6, 5. So there is group all group 5, and we will have a group 35 divided by 6 in a group 5. Okay, then you minus 5, so you have 0.3. Then there will be one group with extra 1 people, something like that. Okay. Oh, even okay. So and then you need to use MATLAB to perform this convolution. Okay, later on I will provide the instruction. You will need to provide some reports, and then you also need to create some video in order to ensure that actually you do this work, not you put somewhere, you get from somewhere. Okay, maybe you ask some platform to do the question for you. Okay, I cannot allow that. So one of the way to actually to double check is actually you provide video. Okay, you will provide video. Depends on the group leader. Maybe only one present in the video, or maybe the entire group present. How actually you obtain from the question, I mean how you settle from the question until you simulate in the MATLAB, how you get it. Okay, means from process A until final process. Process A said, for example, this is question, how you going to approach it, blah 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 blah, and then until the MATLAB. Okay, so you simulate to me how you get it. Okay. So I have the final now. I need to see. Okay. I share now. Maybe some of you already have this. I mean, if you have sit for final, you should know already. Okay, so scroll, blah blah blah. Okay, this is your final. Okay, you can see even the live lecture later. You can see. You can stop the screen. Okay, but I want to go directly to the question. To the one that given. Okay, so what is given to you actually is the integration formula, the trigonometric identities, the Fourier series. You can see the Fourier series given, and then this one is also given, SQ, this one also given, Fourier components, and this is Fourier transform. Fourier transform is you will learn later on. Okay, it is in the later chapter, and then Fourier transform pairs. Okay, and this one I think I will provide this in the e-learning. I put this in learning for you guys. Okay, I will put this into e-learning. This appendix. I put this e-learning to appendix. And normally in test, we will not provide this full appendix. We will not provide this full appendix if, okay, so you guys need to be alert. If we give you this in the test, meaning that you need to use that. But if you don't have that, I mean, if you don't have this appendix in your test, most probably, it's not guaranteed. Most probably you don't use it. So you need to, you need to understand the hint sometimes. Okay. Because normally in test we will not give that. But if we give that, maybe you need to use it. Okay. But in final, regardless you use it or you don't use it, we will give you the complete formula. Okay. I mean, we will give you the complete appendix. So this is good. Rule of thumb. If it's given in the test, more high chance that you need to use it. Okay, you see a lot of appendix. So I need to see from the. This is lecturer. This one is cannot be shared to students actually. This final, because we have this side. Okay, I will share this one. I think this is the latest one, the latest appendix. Okay. Okay, we finish with that. And then tutorial. Tutorial is a bit more, I think tutorial is also challenging. Where is the tutorial? Not sure where. Tutorial. I'm not sure if you, I highly suggest, actually I already give you guys some tips last time. What will be asked in my quiz, like this and like that. Okay, then I just pre-define again, make it more narrow. It is some of them is modification of tutorial 1 question, some, not all. And too difficult one is not coming from tutorial. Okay, so this one, the tutorial 1, okay, tutorial 1. Okay, so you guys need to do this, all of this, okay, all of this. And if you have problem, I'm not sure if you have problem, how we're going to do, because we cannot cover this in class for sure. This is a lot. My class in class is actually try to grab you down. To make you strong in your foundation first. Okay, before we go to difficult question. And if we go to difficult question, we waste 1 hour limited tutorial time. Okay. So you need to do all of this. Okay, you need to do all of this. Some of them will be used to in your quiz 1. I'm not sure you have seat for your quiz 1 or not, but your quiz 1 is due today. Due today, what time? Where is quiz? Is from 12:01 a.m. until 11:59 p.m. Okay, and I already remind you guys, you need to be on stable network, because if you not, I would not entertain. If you guys cannot, you guys will get zero marks. Because I already remind, it is open from 12:01 until 11, and you need to be on the good internet network. I think most of you guys, maybe you will do it tonight, because I didn't see any student yet. Any student? No student yet. Yeah, no student. Okay, 0. Okay, so all the best for the quiz. Okay, and just like I told you guys, quiz is just a small portion of the test 1. Test 1 cover all, chapter 1 to chapter 2. And then let me see if we have. Do you guys need to pass this question? Maybe I only give 1. Do you guys need pass this? Okay. So I suggest that, okay, I will try to find past test. I try to find past test at least 1. At least 1, I think I have in my collection. I need to see first. But the rule of thumb is that, okay, for proper learning, we already finished our lecture. Okay, let me stop the recording first. I will